Welcome back, students. Student, in today's module, we are going to study about a very interesting and important topic called as elementary row. In a bracket, I have mentioned or column operation, but basically we are going to do only with what? Row operation. So that is what we have to study. We call it as elementary row operation. So what do you mean by this term elementary row operation? First of all, theoretically, I want to explain to you people. So please pay attention. An elementary row operation is an operation of any one of the following three types. Like if any of the three things are happening in the operation, then we can say that the operation is based on the elementary row operation of any given matrix. So the first is called as interchange of two rows or column. So if of a given matrix, if I am interchanging the row or column of the matrix, we call it as one of the step of elementary row operation. The next is the multiplication of any row or a column by a non-zero real number. That means we can multiply any scalar to any row or a column, but it should be non-zero. The next is the addition to the elements of any row or column, the corresponding elements of any other row or column multiplied by any non-zero real number. It means what? Suppose if I am taking row 1 and row 1 I am adding to row 2, but with row 1 I have multiplied a scalar. So that also can be done. So I just want to, you can say, represent the operations here. Like suppose if you are interchanging the row and column, so you can write here R1 tends to what? R2. Suppose if I am interchanging the column, C1 tends to what? C2. So these are the basic operation that you can do. So here it indicates that you are interchanging the rows and column. Suppose for the second step, suppose if I am writing here something like this here, like R1 tends to, okay, A times of R1. That means what I am doing to the whole row, I am multiplying a scalar A, and that scalar A should be what? Non-zero real number. Okay, so that is the second step. For the third operations, what is written here, again I am explaining the addition to the elements of any row or a column, the corresponding elements of any other row multiplied by any non-zero real number. Like suppose if I am writing an operation here, the operation is denoted as R1 tends to R1 plus A times of R2. So here one row is being added to another row which is being multiplied by a scalar. So if any of these operations you can see or you are doing in any matrix, those operations comes under the category of what? Elementary row, and if you are applying to that column, we call it as what? Elementary column operation. Okay, now what will be the basic use for this? For that we have to study one more thing, which we call it as what? Invertible matrices. So what is the meaning of this term invertible matrix? Let A be a square matrix of order n. Suppose if I am taking a matrix A here, and that is a square matrix of order n. So suppose take the elements 2 of the matrix I am taking here, like suppose the order is what? 2 by 2, and the elements I am assuming for the matrix A, you can take anything, like I am taking 3, 7, 2, 5. Suppose if I am taking 3, 7, 2 and 5. So this is the square matrix which I have taken of order 2 by 2. So here you can say that the value of n is nothing but what? 2. Then A is called invertible if and only if, that means it is the necessary condition to occur, there exists a square matrix B. That means A will be set to invertible only if the value of B will be a square matrix of the order n. The given condition will be what? A multiplied to B or B multiplied to A will be always giving us a what? Unit matrix of the same order for which A was being considered. Am I clear? Again I am repeating. Take the example that A is a square matrix of order n. Okay, then we call that the matrix A will be invertible only and only if there exists a matrix B of the same order of A such that it satisfies the criteria A multiplied to B will be equals to the unit matrix, or B multiplied to A should be also equals to the unit matrix. Like I am giving you one example. Here A is a square matrix for which the value I have taken 3, 7, 2, 5 of order 2 by 2, and again B I am taking as order as 5 minus 7 minus 2 and 3. B I am considering 5 minus 7 minus 2 and 3. the order of this is also 2 by 2. So first of all, let me check that whether A is invertible or not. For that, the condition necessary has to be satisfied. So let us check for the condition here. What I am doing, first of all, I am multiplying A into B. So I am writing here A, B. It means what? First of all, the matrix A will be written, which is 3, 7, 2 and 5. The order is 2 by 2, and in front of that I am going to write the matrix B, which is 5 minus 7, then it is minus 2 and 3. Let me do the multiplication here, children. So please do the multiplication. 3 5 the 15, minus 7 2 the 14, 7 3 the minus 21, plus 7 3 the 21, 5 2 the 10, minus 5 2 the 10, 7 2 the minus 14, plus 5 3 the 15. So what I am going to get, tell me children here. Here I am getting 1, 0, 0 and 1, which is the unit matrix of order what? 2. So the value of AB is what? Unit matrix of order 2. Now what I am doing, I am using the commutative property. Like suppose if I am multiplying B with A. So tell me children, what is the element of B? 5 minus 7, and it is what here? Sorry, 5, this is minus 7, this is minus 2, and 3 will be multiplied to what here? It will be multiplied to 3, 7, 2, 5, and you will be noticing children, you will again get the same value 1, 0, 0, 1, and that is equals to I2. So that means we are satisfying the condition that AB will be equals to the value of BA, and that is equals to the unit matrix of order 2. Then we can say that the matrix A is invertible. Again, I am repeating the, you can say, condition here. When a matrix is said to be invertible, a square matrix of order n is said to be invertible if there exists a matrix B of the same order in such a way that the product of the two matrices will be giving us an identity matrix of the same order. So this is the necessary condition for the matrix to be invertible. Now in the next module we are going to study about the operations and the sums, that how to, with the help of the elementary row operation, we can find the inverse of a matrix. Thank you all of you.